How to measure current that is going through a resistor using a potentiometer. Now this is the setup of the circuit that we will be using. Our intention is to find the amount of current that is flowing through this resistor, Rs. So of course, our primary circuit is as usual. We have a driver cell and a variable resistor P1. Then this is our slide wire AB, and this is connected to our secondary circuit. Our secondary circuit is having an EMF, a standard cell whose EMF is known. That's why we are calling it ES. And we have this other circuit down here that is containing a variable resistor, a cell, and a resistor Rs, and we need to find out the amount of current that is flowing through this Rs. Of course, we have switch S here, which can either be connected to position 1 or position 2. When we connect this switch S to position 1, it means that we have killed this lower part of the circuit when we connect this S to position 1. And so it means that the secondary circuit will be only that. That will be the circuit. And now, of course, when we connect S to position 2, it means that this portion is killed. It's redundant. It's no longer actively involved in the circuit. And so it means that our AJ will be balanced against what is here. And now here, for us to be able to find the amount of current going through Rs, we need to first find the PD per unit length. So the two major steps here is first of all to find the PD per unit length of AB. That is the same as saying we first calibrate this potentiometer. Then after finding the PD per unit length of AB, then we'll go ahead and find the amount of current going through this resistor Rs by balancing this Rs against the slide wire. So to begin off with our experiment, first of all, like I had said earlier, we first calibrate the potentiometer wire AB to be able to know the PD per unit length. So we do that by first of all placing S in position 1. We place S in position while when K is open. Of course, when K is open, it means that the protective resistor is within the circuit. So when S is in position 1 and K is open, we move this jockey along the slide wire AB, and then we get an approximate balance point. And that approximate balance point is got when the galvanometer shows no deflection. So after that, we close K. When we close K, it means that now we've bypassed this protective resistor by closing switch K. And then we go ahead and find the accurate balance point. And when we get the accurate balance point, we go ahead and find the corresponding accurate balance length that is corresponding to that accurate balance point. And of course, we know that at balance, the potential difference across the balance length is equal to the potential difference across, in this case, since S is connected to 1, it's going to be equal to the potential difference across ES. And this will be it. That ES, which is the PD, is going to be K, which is the PD per unit length times the balance length we got. And when we make K the subject of the formula, K is going to be ES over L. K, therefore, in this case, is the PD per unit length. Now that we've obtained the PD per unit length, we go ahead and find now, we balance the potential difference across this resistor, the standard resistor, whose resistance we know. We balance it up against the slide wire. So how do we do this? We do this by connecting S to position 2. Of course, when you connect S to position 2, while K is open, we go ahead and tap this jockey along the balance length, tap this jockey along the slide wire until we obtain a point where the balance point shows no deflection. And after obtaining the point where the balance point shows no deflection, we will have obtained an approximate balance length. So we go ahead and find the accurate balance length by closing switch K. When you close switch K while S is still connected to position 2, we still move this jockey along the slide wire AB until we get the accurate balance point. When we get the accurate balance point, we go ahead and measure the accurate balance length corresponding to that accurate balance point, and we go ahead and record it. Of course, the potential difference across AJ will be equal to the potential difference across this standard resistor. And in this case, the potential difference across the resistor, standard resistor, which is I times R, I being the current going through the resistor, times the resistance Rs. The resistance of the standard resistor is going to be equal to the potential difference across the portion of that wire of the balance length, which so happens to be the PD per unit length times the balance length L. And this is our equation 2. So since we already got the expression for the value of K, which is the PD per unit length, which we got in our equation 1, which is right here, we go ahead and substitute for this value of K in this. So it means that just like we did here, IA is equal to Rs times KL. This value of K is substituted. We substitute for the value of K from our equation 1, and we get an expression. We make IA the subject of the formula, and this is the expression we get. So we are able to find the amount of current flowing through that standard resistor from this expression, this being the EMF of the standard cell, the balance length, the respective balance length we've been getting in our experiment, then the resistance of the standard resistor. And that is how we measure current flowing through a resistor using a potentiometer. This brings us to the end of this video. Thanks for watching. Feel free to check out other excellent videos on the channel, and don't forget to subscribe. For Kisembo Academy, this is Arnold Rangakuramia helping you manifest excellence.